Okay, here I am again for the same subject which I discussed a moment ago, and I think that our English speaking friends should also be able to get this information. And so I'll do my videos, I will do in bilingual, in Dutch and in English, because for them it's as well important to know. Okay, I had a discussion with a certain guy, Frogan Orange, and he said, well, that the sun cannot shrink and so on. Well, I'll give you some arguments why the sun has to shrink, and it cannot be different than that it shrinks. And I use that. I will use the fusion physics for it to explain why it has to shrink. And I'll take some books. Where did I leave them? I left them over there. Sorry, I'll take them even. I'll take them even too. No, that's one. Yeah. I have a book I studied on the certain level on the high school, and this is about physics, nuclear physics. This is one of the subjects, and I showed a table in which this table. I know it's not most likely not well to see the exact details, but I put them on the board, as you can see. And so I will discuss, but that you know that I'm not faking the whole stuff. Well, this is the table I drew over, and this is the graph I took to use for this argument, and I'll zoom it out so you can see that it's indeed this graph. And zoomed out, zoomed out, zoomed out. Okay, this might be far away. I mean, I know that the details are not visible from a certain point on, because the resolution of the camera and the YouTube thing is distorting the resolution a bit. So I know that the details will not be visible, unfortunately, but that's the consequence of this medium. But you saw that the graph was actually a ski jumping thing from the first part, which I would not prefer to jump if you it's too style, yeah, too steep. Sorry, too steep. Well, but I showed you the graph, and this graph has been taken from this book. It's a study book. In Dutch it's VWO, voortgezet wetenschappelijk onderwijs. Well, it's a certain level at high school, the top grade, top level of high school. This is written in Dutch. No problem, I'll translate it for you, so I don't have to rewrite it in English and so on, but I'll translate it for you. Okay, why does the sun has to shrink based on fusion physics? Well, I'll go to the table first. Yeah. First part is that if you look at, if this is an atom, yeah, then, and if you regard the mass per nucleus, yeah, the mass reduces per nucleus if you go from a lower atom, hydrogen, to a higher atom number. Well, this is increasing atom number Z. Yeah, so the elements are increasing from here, hydrogen, helium, lithium, boron, beryllium, nitrogen, carbon, oxygen, etc., and so on, and so on. Wow, this is increasing atom number. Yeah, but you see, it is known that the mass per nucleotic particle is decreasing, yeah, up to a certain level, till iron, yeah, which is Z number 26, and from there the mass is increasing. Well, mass and energy are equivalent, yeah, Einstein showed us E is mc square. And so energy is with a multiplication factor of c, which is the speed of light, squared. Yeah, speed of light times the speed of light. Yeah. So mass and energy are equivalent. Yeah. Okay. Well, what you see here is that the mass per nucleotic particle is decreasing up to iron, and from iron on it's increasing again. Yeah? But surely in the first part of the graph, you see that the decrease is high. Yeah? The graph is dropping rapidly. Yeah? Like in a ski jumping thing. I would not like to start here as a ski jumper. Yeah? so steep it is. Yeah? But what does it mean? Okay. Nucleotic particles like hydrogen and hydrogen, they are fusing in the sun. Yeah? The sun is a big gas plasma ball. Yeah? It's a big, and the gravitation is squeezing it together. That's why fusion appears. Yeah? But it's a gas-like thing. Yeah? And hydrogen is fusing to helium, and helium is fusing with hydrogen to lithium, and lithium with and so on. So going to beryllium, boron, beryllium, and so on, so on, so on. Yeah? So the first thing is particles are disappearing. Yeah? If I take two hydrogens and I fuse them to helium, yeah, two particles become one. Yeah, and two heliums together becoming I have to look, beryllium. Yeah, they leave the entrance. They leave the theatrical scene. Yeah, two particles become one. So one particle is actually leaving the theatrical scene. Yeah. So the number of particles is reducing. So that's one argument to say, okay, the sun must shrink. Okay. Now you have less particles, and the energy released per reaction, going from a low atom number to a higher number, the energy released, you can see that if I take a particle here and I let it fuse to a particle here, yeah, and I take from that here to there, yeah, the energy will decrease. The energy amount released will decrease. So the particles will decrease, and the energy per reaction will decrease. Yeah. So that implies that the whole. So the energy released is also averaged on less particles. The released energy, which is decreasing, is spread out over less getting particles. Yeah. So there are two big reasons why the sun has to shrink. Yeah. Well, so less particles. Yeah. And going from a higher atom number, there is less energy which is released, especially in the beginning, because the graph here is the steepest. So in the beginning, this effect is the most. Yeah.